our first presenter, Clemens Voigt. Welcome on stage. Clemens is a PhD candidate and scientific researcher at the Fraunhofer IKTS in beautiful Dresden. And let me have a look. Clemens will share with us screen printed magnetic field sensors and flexible polymer foils. Clemens, camera is good, sound is good. Feel free to screen share. Perfect. The stage is
Yeah,
yours.
thank you very much. Sorry for the delay. And thank you very much for the kind introduction. I want to talk about screen printed magnetic field sensors on flexible polymer foils today. And on my first slide, I want to give you a quick motivation. What is a magnetic field sensor and what it is used for? So there are three main applications for magnetic field sensors, which is the detection of position. So the sensor detects linear movement of a magnet. The second one is the rotation detection. So the sensor detects rotating movement of a magnet. And the third main application is the current measurement, because every conductor carrying current makes a magnetic field around it, and the magnetic field sensor can measure then indirectly the current and the amperes, so non-invasive technology. And for this and for the examples, I put here a flyer of one of the main key players in the field of magnetic field sensors, TTG Micronas GmbH, and they put some examples here where magnetic field sensors can be used for the automotive sector only. So there are many applications in the car. So we can start with, for instance, the seat belt presence detection. So is the seat belt fastened or not? Where is the seat position in the car? It can be measured by magnetic field sensors. Then we can go to more advanced application like pedal position measurement or the gear shaft position measurement, and very important for electric vehicles, the motor control, the BLDC motor commutation, or even the current measurement in the batteries. And there are also measurements with arrays of magnetic field sensors, for instance in a tank, how much fuel is inside the tank, and you can put a magnet on the surface of the fluid, and then the magnetic field sensor arrays can detect then the liquid level inside the tank. Okay, so that's for the applications, and on my next slide I want to deep into the physics of the magnetic field sensors a little bit. And we developed two types of magnetic field sensors. One is the large magnetoresistive sensors, and the other type is the anisotropic magnetoresistive sensors. But they have both in common. They are magnetoresistive. That means we measure the electrical resistance of the printed structures, and this resistance changes in the magnetic field. So, and the first type is the large magnetoresistive sensor based on bismuth. And so we print only bismuth structures. And after sintering, you can measure the resistance. And when the electrons move through the conductor and the magnetic field is applied, then the electrons do not follow a straight line. They make cyclotron orbits, so they circle around through a Lorentz force inside the conductor. And this is why we have in these type of magnetic field sensors always a positive change of resistance inside magnetic field. The other sensor type is completely different. It's an anisotropic MR sensor, and they are based on a ferromagnetic material, for instance, nickel iron. So we print nickel iron material, and here it is important how the magnetic field is applied to the structure, and what is the magnetization then inside the printed structure. For instance, if the magnetization is parallel to the conductor, to the current line, then the resistance increases. And when the magnetization inside the printed structure is perpendicular to the current, then the resistance decreases. Okay.